Welcome to Calculus Crush. Today we're going to be deriving the product rule. The product rule is the rule of differentiation when you have a product of two functions. So first I'm just going to write out what the product rule is, and then we're going to work on deriving it using the definition of the derivative. So if we have y of x, which is equal to f of x times g of x, the product of two functions, then the derivative of y prime of x, is equal to f prime of x times g of x plus f of x times g prime of x. This is the product rule. So what we're going to do is derive this rule. In order to do that, we need to start off with the definition of the derivative. So y prime of x is equal to the limit as h approaches 0, y of x plus h minus y of x, all divided by h. If you don't know where this comes from, you can click on this equation and it'll take you to another video where I derive this expression. This is the definition of the derivative, or the slope of the tangent line. Now, all we need to do is substitute in f and g for y of x. So this is equal to the limit as h approaches 0. So y of x plus h would just be f of x plus h times g of x plus h. Minus y of x, which is just f of x times g of x, all divided by h. So this on its own, it doesn't really look like we can do anything. Can't factor out anything common, can't rationalize a numerator, nothing like that. But what we can do is apply a little trick. All of these derivations, power rule, product rule, quotient rule, chain rule, rely on clever little tricks in order to get the expression. So I'm just going to write out the first term as is, f of x plus h times g of x plus h. Now before I write out this last term, I'm actually going to add something and subtract something. I'm going to go minus f of x plus h times g of x plus f of x plus h times g of x. So you can see here, all I've done is add 0 to the formula. I've got subtraction and then addition of the same term. And now we need the last term here, minus f of x times g of x. This here including the minus sign, is new. It's something we're adding to the formula. And this is all divided by h. So just a reminder that this is equal to 0. So we're not actually doing anything to the numerator, we're just adding 0 to it in what you'll see is a clever way. So this is the limit as h approaches 0. Now what I'm going to do is I'm actually going to group these into two different pieces. For the first piece, notice that f of x plus h is common between the two. So we've got f of x plus h times g of x plus h minus g of x, all divided by h. Plus, now this is also the limit as h goes to 0. So I'm actually breaking this into two parts. We've got this first green part over h in a limit, and then I'm putting the limit in front of the second green part over h. So in this second part, notice that g of x is common. So I pull out a g of x and I'm left with an f of x plus h minus f of x, all divided by h. We're getting very close to the end here. The next thing I have to do is apply one of the rules of limits. I'll just quickly write what that rule is. We'll use a red pen here. If you have the limit of a times b, that's equal to the limit of a times the limit of b. Okay. I don't have an h goes to 0, and it doesn't matter. Just want to show. Now basically the limit of two things multiplied is the limit of each one of those things multiplied. Okay. We're not going to prove that, but we need to use that here. So I've got one term and two term. My first term and my second term. And I'm going to put limits in front of each term using this rule up here. So limit of f of x plus h times the limit g of x plus h minus g of x divided by h. Sorry, I'm forgetting the h goes to 0. There we go. Plus the limit as h goes to 0, g of x times the limit as h goes to 0, f of x plus h minus f of x divided by h. If we look closely, what we actually have here, this expression, this is just g prime of x. Remember the definition of the derivative? Here we have g prime of x. And this expression here, this is just f prime of x. Now, if we take the limit as h goes to 0 of f of x plus h, well, we just set h equals to 0, and all we're left over with is f of x. And if we take the limit as h goes to 0 of g of x, well, g of x doesn't depend on h, so it's just g of x. So finally, what we end up having is f of x times g prime of x plus g of x times f prime of x. We're done here. We've derived the formula, but it's not in the order that I like. I usually like to write it, so I'm going to take this guy here and put it in front of g of x, and then I'm going to put this whole thing as the first term, and then I'm going to put this whole thing as the last term. I'll tell you why I like that in just a minute. So let's write out the full expression. Y prime of x equals f prime of x times g of x plus f of x times g prime of x. And there you have it. This is the product rule. We have derived the product rule from the basic definition of the derivative. Now, why do I like to write it in this way? It's because I've remembered in my mind what the product rule is. And I like to say the derivative of the first times the second plus the first times the derivative of the second. Okay? Or you can write it without the function of x and just write f prime g plus fg prime. You can also write it this way. The derivative of fg equals f prime g plus fg prime. Thanks for watching, you guys. If you have any questions, please leave them in the comment section. Please subscribe for more videos on calculus. Thanks a lot. Until next time.